So here we are preparing the wood panels for WISA Woodsat. These are not the flight models, otherwise we would be using gloves and so forth, but we just want to show you what the process looks like. So we have the wood panels. This is the space plywood from UPM, and it has been loaded up to our Nomad 3 CNC, and we have zeroed it out, so we are ready to begin. So first we do the holes for the screws, and then we start cutting the surface. One problem you have working with extremely dry plywood is that when you cut it, it sometimes tends to fracture. And this is why we wanted to do the drill holes like first, so that if there is a small fractures, then we can cut the surface and remove those fractured areas. So this way we will get very clean cuts, and it will like stay sharp and not start shedding pieces of wood everywhere. And next, one other problem with plywood is that even though it seems that it's flat, but if you're talking about engineering level flats, like it's not actually that flat, but it actually has like very small deviations. And of course, when we want to do CNC operations, we want everything to be nice and flat. And so next operation is to use a surface cutter to cut the surface nice and flat, so that all the preceding operations will have a nice surface to work on. When you're milling extremely dry plywood, it tends to create a lot of dust and kind of fine powder, so you really want to get it out with vacuum rather than spray it in. So now the surface cutter has roughed out the part, so it has removed most of the excess material. And next we will cut with a side cutting end mill all the edges, so that they will be nice and clean, and also the holes where the cables will go through. Alright, so last thing we have left to do on this side of the part is that there is like 0.2 millimeters of excess material we want to remove, and we have left that so that we have very fine last cut with an upcutting end mill, so that we can get nice and flat and like even shiny surface. This is very important for us, because if there's any like small things remaining in the wood, it could be removed during the rocket launch in the harsh vibration. So let's do that. So to reference the other side of the part, we drilled a hole through the wood, and now we are taking our position from that hole, so that when we start cutting from this side, all the features from the other side are in the right places. So now the other side is zeroed in, so we can start cutting it. And this time we use a down cutting end mill, so that it drills into the material and starts cutting, and this way we don't get the tear out we might get with an up cutting end mill. And now we will do the main features of the panel. We will do the cutouts and also the sides of the panel. The 3mm end mill we used for the last operation is not small enough to really make sharp corners, so that we could put the square solar cells in. So next operation is very simple. We go to the corners with the 1mm end mill, just to make the corners a little bit more sharp. So if you look carefully at the side panels of WISA Woodsat, you may notice that the sides are ever so slightly curved. And this is so that we don't get any tear out from sharp edges, where the plywood may start tearing out and then remove splinters, which of course is very undesirable during a rocket launch. So to curve the edges in a fast manner, we use this kind of quarter circle end mill, and it just comes and does the corners and then goes off. And next, countersinks. And then we do the surfaces again with the upcutting end mill, since that just leaves the best and cleanest surfaces. Alright, so it starts to now look like the side panel of WISA Woodsat, and now we just need to remove it from the plywood, so back to the side cutting end mill. So here we are, we cut out the frame from the plywood, and now we have the side panel here. It's still being held by the two-sided tape that we used to fasten it to the table, but it's now ready. So this is the process we use to make aerospace parts from plywood. Traditionally, aerospace machining means making crazy parts, machines in very hard materials like titanium and Inconel and so forth. But in this case, our challenges have been quite different. We have been working with plywood, and this means that we have quite unique challenges. For example, we want to avoid any tear out or splintering and so forth. So even though this might look simple now, actually behind this is a couple of months of process of honing the programs and so forth in, together with UPM plywood professionals, with carpenters, and even European Space Agency's material scientists. And of course, quite a lot of just doing it over and over again. But in the end, we have a very nice process. We can make very nice quality parts consistently, and well, this is the result we can see.